Hello, this is Mr. Montgomery. In this video, we're going to be looking at some example problems dealing with lenses and mirrors. This video is designed especially for my online Physical Science 1 lab students to help you with some examples that you can use to go by. I'm going to put a link in the description below to these example problems that we're working on. So in this first diagram, we have a convex lens, all right, and it tells us we're going to place a 56 centimeter tall object. If you're using this simulator, the object right here, the pencil, when you measure its height, it's always 56 centimeters tall. So that 56 centimeters, that is the height of my object. It's placed 90 centimeters from this convex lens. So I set this up right here at 90 centimeters on my ruler. So measuring from my pencil to the center of my lens was 90 centimeters. All right, so that is my object distance. And then over here, it tells us it forms a real inverted image. So you can see this pencil is upside down compared to the object. Now it's cut off here, but right underneath this picture frame, it says real. It's hidden below the box over here, okay? But it's a real image because the light actually converges at this point. All right, and then when I measured the height of this new pencil, it had a height of 112 centimeters, but notice it's inverted. So that means the height of my image is a negative 112 centimeters. An inverted image must have a negative height. Forms over here on the opposite side of the lens. Now, the image is located 181 centimeters from the lens. So in my next illustration, I had to come in here and measure, okay, from my lens to where my image is located. I set my ruler up, and so I measured this image distance is 181 centimeters. Now this is a positive value because it is a real image. A real image has a positive image distance. If it's a mirror or lens, either one, it's always the case. Real image, positive image distance. Okay, so knowing these values, the height of my object distance, my image height, and my image distance. Now we want to make some calculations, and I'm going to set this page over here to the side. We want to calculate for this lens what is its focal length and what is its magnification, and we have formulas to make each one of those calculations here. So let's start with the focal length. That this tells me the focal length equals the object distance times the image distance divided by the sum of the object distance plus the image distance. So this focal length is going to equal my object distance, that was the 90 centimeters, times my image distance, that was a positive 181 centimeters, divided by those two values added together. Now, one of these centimeters, this has centimeters as well, but they're being added together. So that's going to cancel out one of the centimeters on top with these on the bottom. We're going to have centimeters left over for our unit here. All right, so I'm going to do right here 90 times 180, but divided by, make sure I use a parentheses, 90 plus 181. And I get a focal length here of 60.1 centimeters. 60.1. Positive focal length because that was a converging lens. All right, now calculate the magnification. Magnification is the height of the image divided by the height of the object. So our pencil ended up being upside down, it was inverted. So it had a height of negative 112 centimeters. The object, the original pencil, was 56 centimeters. Well, these centimeters are going to cancel out. And so if I do negative 112 divided by 56, I get a magnification of -2. All right, magnification of -2. That tells me that this final image was inverted because it's a negative, but it's twice as large as the original object was over here. Now, let's look at an example using a mirror, a convex mirror. All right, so 56 centimeter tall object. Again, you can see here my illustration where I actually measured the pencil and it was 56 centimeters tall. So that's the height of my object, 56 centimeters, HO. Let's place 60 centimeters in front of my mirror. So you can see again right here where I set this up to be 60 centimeters in between the object and the mirror. And so that is my object distance, 60 centimeters. In front of this convex mirror is a diverging mirror. And then what forms down here in the next picture is a 36 centimeter tall image. So I measured right here my image, came out to be 36 centimeters, but it was upright. It's in the same orientation as the original pencil, so that's a positive image height. But it is a virtual image. It formed 38 centimeters behind the mirror. So again, you can see I'm here where I was setting up my ruler to measure from the front of the mirror to where the pencil was formed. So this image distance is 38 centimeters, but it's a virtual image. That means this must be a negative 38 centimeters. A virtual image will always have a negative image distance. So now we know the image and object distance, we know the object height and the image height. We can make our calculations same way we did before. Focal length is going to be my object distance, which was the 60 centimeters, times my image distance, which was that negative 38 because it was a virtual image, divided by those two added together. Well, we got a negative sign here, so really we end up subtracting. So I'm doing right here 60 times a negative 38 divided by parentheses 60 minus 38, and I get a focal length of negative, I got 10, we'll call it negative 104, right? Centimeters. These two combine and cancel with one of the ones on the top there. Okay, negative 104 centimeters. Now there's definitely a little bit of error in my measurements here and trying to estimate exactly the height of this thing and its image and object distance. So there's a little leeway in there. Magnification. Okay. Image height. So our image was positive 36 centimeters because it was upright, but our original pencil was 56 centimeters tall. Those centimeters are going to cancel out. 36 divided by 56, we have a magnification of 0.64. Okay, that positive value is because my image was upright, but this value is less than 1 because the image was reduced. It was smaller than the object was in the first place. So I hope those example problems give you a good idea of the calculations and the problem types that you're going to be solving and working out after you perform your experiment or as you perform your experiment. And as always, if you need more help, then feel free to reach out to me, and y'all have a great day.